गुड मॉर्निंग टू एवरीवन। आज माइक्रोवेव में हम यूनिट फर्स्ट का लास्ट टॉपिक दैट इज़ माइक्रोस्ट्रिप लाइंस एंड इलेक्ट्रिक रेजोनेटर डिस्कस करेंगे। इसमें मोस्टली एक छोटा सा पार्ट है दैट इज़ ओनली द इंट्रोडक्शन ऑफ द माइक्रोस्ट्रिप लाइन एंड द इलेक्ट्रिक रेजोनेटर। सो व्हाट मीन्स ऑफ माइक्रोस्ट्रिप लाइंस? The microstrip line is the type of electrical transmission line which can be fabricated with any technology where a conductor is separated from a ground plane by a dielectric layer as a subtract is called microstrip line. Just like a arrangement of a conducting sheet that is separated by a dielectric medium that is also known as substrate, and that is in between these two there will be the transmission of the energy, so it is called the microwave strip line. Microstrip lines are used to convey the microwave frequency signals. And how it is fabricated, and this is the figure. See here, that is a ground plane is there, that is the D, and a dielectric medium that is also known as the dielectric substrate having the permittivity epsilon r, that is the C, having the height h, and above it there is a conductor whose width is the W and the thickness is the T, and above that conductor that is the upper dielectric medium, and mostly it is used as the air that is open. So this arrangement is called microstrip lines. Typically the realization techniques are the PCB, printed circuit board, aluminum coated dielectrics or the silicons. Microwave components like the antenna, couplers, filters, power diodes can be fabricated from the microstrip as metallizations are over the substrate. Microstrip are much less expensive than the waveguides, and it have the more lighter and the compact. It is a parallel plate transmission line having dielectric substrate, the one face of which is metallized ground and other top face is a thin conducting strip of the certain width W, that is just like that. ऊपर भी मेटल कवर हो जाए मान लो, इस तरह से भी हो सकता है, और नीचे भी मेटल कवर हो सकता है, और बीच में डाइलेक्ट्रिक मीडियम डाल रखा और उसके ऊपर हमारा जो स्ट्रिप है वो हो सकती है. Now disadvantage of the microstrip over the waveguides. Due to the opens of the microstrip structure, they have high radiation loss or the interference due to the nearby conductors, so it can be disturb the signal. This can be reduced by choosing the thin substrate with the high dielectric constants. Due to the presence of the air at the interface, discontinuity in the electric field and magnetic field will be generated, and due to this there will be the mixed dielectric transmission structure is there, field pattern. In the microstrip lines, there is also, we say that for the electric field there is from the top to bottoms, and this is the direction of it, and similarly the magnetic field also in the circular forms. So these are the field patterns for the electric and magnetic fields. The lines does not support a true TEM mode at the non-zero frequencies. The line is also the dispersive. Now, what are the some characteristic impedance of it? The characteristic impedance Z is function of the strip lines width W, thickness T, and the distance between the lines and the ground plane, and that is the H, W, and the T. So this Z0 equal to the 60 by root of the epsilon r logarithm of the 4h by the D. H is this one, and the D is the height of this one, diameter of the wire if we are using that one. In place of this rectangular strip we are using the circular wire. So epsilon r is the relative dielectric constant of the dielectric medium, and h is the distance between the strip and the grounds, and the d is the diameter if the wire over the ground is the. So if the W is greater than the h, then the Z0 equal to 377 by the root of the epsilon r h by W. Now dominant mode for the propagations in these lines is the TEM, and the characteristic impedance depends on the strip width W, thickness of the dielectric constant, and the dielectric constant of the substrate media. Most of the energy propagates in the dielectric just below the strip conductor, and the remaining around the strip. Now the attenuation constant, that is the sum of these two. First, alpha equal to alpha d plus alpha c. Alpha d dielectric attenuations due to the dielectrics in substrate, and the alpha c, that is the ohmic attenuation constant due to the ohmic skin losses in the conductors. So there are the two types of this one. Quality factor of the microstrip lies is very high. However, it is limited by the radiation losses of these substrate. So QD equal to the 1 divided by tan theta, where theta is dielectric loss constant that we have discussed earlier. Now the types of the microstrip lines, only there depends on the geometry of this one. Let us suppose embedded microstrip line. Here the conductor is in between a dielectric media. Inverted microstrip line, that is the conductor is below the dielectric slab, and it is in between dielectric slab to the lower conductor plates. And the suspended MSL, that is the dielectric constant and the strip are the in between the air. And the last slotted microstrip lines, that is the gap between these two, and the conductor is broken into two parts. Now the second part of this one, that is dielectric resonators. What is the definition of it? The piece of dielectric material, usually ceramic, is used, that is designed to function as a resonator for the microwave and microwave bands, like this one, and it have the abrupt change of the dielectric medium from outside of this one working. The microwave are confined inside the resonator materials by the abrupt change in the permittivity at the surface, so it bounces back and forth between the sides. So it forms standing waves are formed having the high dielectric constant and the low power loss. The resonant frequency is determined by the overall physical dimension of the resonator and the dielectric constant of the metals. The dielectric resonators function similarly to the cavity resonator, except that the microwave are reflected by the charge large change in the permittivity rather than the conductivity of material. This is only the basic difference between these two. Remaining physical quantities are the same. Now, what are the use of dielectric resonators? They are mostly used in the millimeter wave electronics oscillator, dielectric resonator oscillators also, as a band pass filter and as an antenna. Now, what is the resonance frequency of this one? The F equal to 34 divided by A root epsilon r A by L plus 3.45, where A is the radius of the cylindrical resonator and L is the length of this one. So this is all about the dielectric resonators and the microstrip lines. Mostly the question is asked related with the very small questions in section A. Thank you.